Good evening, everyone, and a warm welcome to all the data enthusiasts joining us for the very first webinar of DataStorm 6.0. DataStorm is Sri Lanka's premier advanced analytic competition organized by the Rocktrack Clubs of Faculty of Science, University of Colombo, and the University of Moratuwa. It serves as a dynamic platform designed to challenge your analytical thinking and elevate your problem solving skills with real world data driven scenarios. We are thrilled to kick off this year's journey with an engaging and thought provoking webinar titled It's Not Just About the Model, Rediscovering the Value of Data Science Fundamentals. Today, we are honored to have with us Mr. Thenuwan Jayasinghe, passionate data science consultant and trainee at the Boffin Institute of Data Science. Mr. Jayasinghe brings with him a strong foundation in data science principles and hands-on experience in applying them to meaningful, impactful projects. So, before we hand over the session to Mr. Jayasinghe, here's a quick note. In a world where flashy algorithms and AI jargon often take center stage, it's easy to overlook the basics. This session will remind us why mastering the fundamentals is still and always will be at heart of great data science. So sit back, get ready to be inspired, and let's dive deep into the core of what makes data science truly powerful. Over to you, Mr. Tenuwan.
Thank you, Nehans, for that introduction. Let me share my screen. Yeah. All right. So once again, very good evening to you, and thanks for inviting me for this webinar today under the topic of it's not just about the model, rediscovering the value of data science fundamentals. The reason that I've chosen to discuss on this topic is that often some of the fundamental aspects of a practical data science work or practical data science projects, it's beyond, or rather the model is like coming in one of the latter stages. Before that, you have to do a lot of things, so that only your model will work or work as expected. So in today's talk, actually, I won't be mentioning any of the models or whatever. I'll be sticking to the basics, right? So there we will explore a little bit about different aspects you have to go through, and we'll share some knowledge, some practical experience that I've gained throughout the past couple of years, and which will I will try to give you some practical aspects of a data science project. Right, so we'll get started. Right, so before starting, let me give you a brief introduction about myself. Right, so as you know, my name is Thenuwan, and now we are working. I'm working at a data science startup, or rather project consultancy based startup called Boffin Institute of Boffin Insights. So that is our data science project arm, and also here we work with multiple clients in Sri Lanka, overseas, and we pick up their business cases, and we assist, or rather we deliver data science projects, right? So the other arm of us is called Boffin Institute of Data Science, where we do trainings to corporates and individuals, and we offer certifications in data science, data analytics, where we've partnered with the Data Science Council of America. We are the authorized education provider here in Sri Lanka, and we offer certifications offered by them as well. So that's about us, about where I work now. Before that, actually, I was also an undergraduate of University of Moratuwa, 2009, 2014. at the Department of Transport and Logistics Management. And later on, I completed my master's in Technical University of Munich in transportation systems. Actually, that is where I've first got my first kind of experience into data analytics. I mean, data science. So the popular concepts that we have been, what I initial seeds of that I got through that during that program. And for my master's thesis, I joined a Singapore-based company called Tum Create. That is where during my master's thesis, I was able to apply some aspects of data science where I mainly worked with traffic simulations. So thereby I could further gain some experience what I've learned through my academic during the modules. So that's how I kind of entered into this space. And then as professional certifications, I have a certified senior data scientist that is offered by Data Science Council of America. Also, scikit-learn associate level practitioner certification also I've received. So that is a bit of about myself in relation to this particular field or the topic that I'm discussing today. Now, I also want to know the audience as well. So if you could scan this QR code that is given here, so that I can and give. There are a couple of like 3-4 questions. So if you could take a minute so that I can get an understanding of the composition of the audience today. I believe the quiz is working. If not, just let me know. Yeah, I think the responses, I'm getting the responses. It will take another minute. So that you can. Right. So I got around 16 responses now. I think there are around 30 plus members. Right. So I got around 20 responses. So let me share those as well. So I think Yeah, I think you can see the results. So yeah, so almost all of you are undergraduates, right? So around, more than half of them, just starting in data analytics, right? So yeah, so then majority is from computer science background, IT related stats. So there are some non-engineering students as well. In terms of familiarity, yes, so there are a couple of experts also, a couple of new or rather fresh entrants to the field or this particular domain. So good, good. So we have kind of a like 100% undergraduate audience. So I guess the talk that I'll be giving will be more relevant to you, right? So thank you for your feedback. Right. Okay, so then I guess we can start this session, right? Now I want to first take you through a typical data science journey, or rather, actual how actual business problem works, right? So it first starts with understanding the business problem, right? That is the essence of any data science work. First, you need to kind of know what you're trying to solve, right? Um, then what happens is you you try to understand the data sources available to you, right? Because you have to work with the available data sources of that organization, right? So you need to have good sort of understanding about the data that is there, like what could be the issues of it, like we'll discuss that, but need to have a basic understanding of the data. Then you have to go through this process called feature extraction, right? Where I'll provide or I'll put more weight into my talk today. Uh, then once the features are extracted, only you can do your modeling or whatever the analysis that you make. It could be a simple, let's say, a BI model, that's a business intelligence model, or a predictive model like a machine learning model, right? Uh, Mostly those, right? And then once you create your model and once you get the insights out, you have two options. I mean, either you present the results here. What I meant by presenting the results, it could be a dashboard output or else a report or some API endpoint or whatever the output that it can be, right? Or simply a presentation, right? Or else, or this both happens in actual cases, you have to deploy whatever the model that you create, right? So this is what a standard, steps. There are different models are there that, but in summary, this is what you do. But the one of the additional step in data science work is that you have to circle back after once the model is created. Sometimes certain new things will appear, certain new questions you might have to answer, so you may have to go back to the beginnings. You may have to look for other data sources. You need to extract more features, right? You need to create another model. You need to update your dashboard. You change the deployment, right? So this happens, right? So data science is not like kind of a waterfall approach. You don't you finish one step and move to the other one. So it's more like an iterative approach, right? So that brings a lot of challenges, and at the same time it's a exciting area to be in, right? So I'll take you through each of these steps, right? And we'll discuss what are the elements in each of these uh, areas. Now, the first thing that we have to do is to frame the problem, right? Understand the business problem, right? Because it's not the it's not a technology that you're going to test out or deploy, right? So you don't have a ready-made solution in your mind. right? And then go apply to organizations. If that is the case, almost chances are sure that your data science project will become simply a science experiment or become a failure mainly, right? So we need to first understand the problem first and then create our solution, not the other way around, right? We don't go with a ready-made solution to a client and ask him to, okay, this solution is the solution that you want. That's not how data scientists. Yeah. So so then the most of the projects, if you look at the data science projects, the business users or the business high level executives, they have very open-ended questions, right? It can be a simple pain point that they have, right? So how maybe reducing costs, maybe increasing sales, maybe complying with the regulatory requirements, right? And for them the solution is often not clear. They are experts in this area, but when it's come to data analytics, data science, they are not very sure how to tackle that problem, right? So that is where we as data scientists, data analysts, that is where our expertise comes in, right? So we have to understand the problem that we are trying to solve, and try to agree on, okay, what kind of solution that we are creating, right? Because for a given problem, or rather when it comes to open-ended or rather very vaguely defined question, uh, the the solution that you give has to be kind of, you need to agree on the first, right? Because you need to have at the very beginning you need to have a good kind of sort of the definition of done before starting the project. You need to agree with this, the project owners, or rather from the client side, right? Else what will happen is that once you start working on the project, everyone will lose the focus, right? No one will know what you are doing, and that's the worst thing that could happen. Or else, if you are doing well on the project, the client might ask more things to do, right? So what you call the scope creeping kind of work also can happen, right? So it's always good to kind of document it, agree, go for a letter of engagement, and then seal it, and then start working, right? So you have to document and agree the deliverables that you get, right? Else what will happen is you might divert from the initial what you call this agreements, right? But however, don't start immediately start to solve in the problem, right? This is the usual gut feeling that we have, or rather the go-to approach most of us have. But rather than doing that, first you need to like further understand the problem, have multiple meetings with different stakeholders, right? Whom you think that your solution that you deliver will have an impact on multiple stakeholders within an organization. So try to understand, identify them, have meetings with them, and try to understand what are their pain points, right? Because if you create a solution, and maybe it could be the best solution, but if they don't understand it, or if they don't trust it, and if they don't use it, there's no point of or or no, there's no use of that solution, right? So, and the other side of it, other aspect of that, the other aspect. Yeah, so I have a question. So I'll take these questions towards the latter part. I guess one of the co-hosts can assist me on that during the latter part. Okay, I have some direct messages as well, so I'll take it towards the end of the talk. Right. So I was telling what happens when when you don't have the meetings with the stakeholders who will be affected by this solution, is that they don't know what's going on, and they think, okay, this is the solution that this third party is developing, And then there'll be expectation differences in expectations, right? And there'll be very, heated discussions, arguments, and all, right? So try to understand whatever the issues that might come at the end of your project. Try to, try to guess them, right? That also comes with experience. And try to solve those problems at the very beginning stage as much as possible. I know that you can't solve all the problems, right? There will be issues, but try anticipate and try to solve them, right? So these things you have to do before starting anything. There's a bit of work to be done, right? um, then let's say, okay, you agreed on a problem statement that you're trying to solve. You set the deal, or rather agreed on the deliverables, and then you started the project, right? So then what you'll have is, you will have access to data, right? So initially you might have to send a data request, right? You might have to say, okay, these data are the ones that we need. And usually client will either give you access to their databases, or rather maybe sometimes they might get a file dump, and then give access to you so that you can start working on those files and start working on your solution, right? So let's say you started that, right? Now, a lot of people, or I mean, organizations may say that, okay, our data is the cleanest. We have, all the data governance policies in place. We have the very, very clean data to get started with, right? So, I mean, there's no such thing as clean data, right? Every data sets have, you can find issues, right? So I mean, don't trust that, right? So always, go with the approach that, okay, you have to do a lot of data preparations, cleanings in this stage, right? And at this point, one of the good thing that you have to do is that, maintain a data dictionary, right? By yourself, right? Whatever the files that you are working with, or rather whatever the tables that you are working with, maintain a small spreadsheet, Google Doc, let's say, a Google Sheet. Then name have for each data source that you are working with, open a sheet for that, and then name the fields or the columns that are there, what might be the data cleaning steps that is required in that, right? And mention anything that you think that is required, right? Because why is that you are working, I mean, when you start a project, you work for a long period of time, let's say usually 9 to 12 months of period of time. And whatever you do, it's better to start documenting at early stages, right? Else what will happen is, I mean, you will think that, okay, this is like, I know what I'm doing, right? So no point of documenting, it's a waste of time. But these little noises later on adds up, and then later it you have to spend lot more time to find even a small thing, right? You don't have, I mean, sometimes if you don't document things, you may have to go through the mail chains up and down multiple times, right? So that will be a very hectic task, non-value adding activities, right? So start documenting at early stages. Whatever the treatments that you do to your data, document it. Maybe also in your code also you can comment it, that's also possible. But for a non-technical audience also, like, keep this kind of a so they kind of a documented form, whatever the changes that you do, or whatever the data sources that you work with, whatever the information you need to keep there, right? So, and also when starting the project, now this comes with bit of practice, right? You need to have like set of prepared, prepared questions that you will be checking with the data, right? Now, for example, I'll be taking a small practical use case. Let's say you work with a finance company, right? Now, this finance company will have financial transactions, right? Let's say customer comes and uh, do payments, right? So one of the questions that you can ask is that, okay, from the data owners, right? You can ask, okay, how many records per month or per day will be generated on average, right? So then they'll give a ballpark number, right? So then you can do a quick group by and aggregation and get a count, and you can kind of validate those numbers, right? Then and there, right? Because if not, let's say for some reason you didn't get the entire data set, some mistake, right? SQL query related issue or whatever, right? I mean, people not doing mistakes by, I mean, those are mistakes, right? They don't want to like put you on trouble, but something might sometimes things might go wrong, right? Um, so it's better to check these, right? So like so on average how many records will be created daily, right? So then you need to identify what could be the unique ID. Is it a contract ID or the customer ID that is unique in this table, right? Or rather something like this, or a combination of both those keys will create unique values, right? And then whether you need to check duplicates, whether there are duplicates for some reason, right? And then delete them, and understand the minimums, maximums on a particular field or particular column. What could be a minimum value? What is a negative value mean? Whether this column can have negative values, right? So those are very basic stuff, but you need to ask those questions, right? So as you work on a project or multiple projects, you will have this kind of a battery of questions, right? Ready-made questions that you will be checking with the data set. So as you work on a projects, like keep those things also documented. Those are your learnings, right? Keep them documented and have them ready. Whenever a new project comes, you can check those questions and make sure that you won't be doing any errors in the data preparation stage, right? So, data cleaning is very, project specific, right? Every data has, what you call the data is messy, right? Every data is messy in its own way. So you need to tidy them up, right? So now most of the cases, there could be white spaces, right? There are dates, times, there are like a lot of issues, right? So you may have to write user defined functions for all of them and make sure that they are well clean, right? Right. So so those things you have to do, right? So I mean, obviously, any data analyst has to do those things. I mean, in reality, this is also the case, right? Now, once you do that, right, then you can move to the next stage of what you call this feature extraction, right? And this is the most creative part in any data science work. It's not modeling comes after, but this is where you put your creativity to action, right? Um, Now, for this, you need domain expertise, right? Now at the moment, like almost all of you are undergraduates, but some of you might have a domain specific degree, right? For example, in finance, or let's say on logistics, supply chain, marketing, right? And also sometimes you may like highly technical, like IT or data science related skill will also you acquire, right? So, but as you move to the industry, right, you will be placed in any particular domain, right? It could be a finance domain or like logistics industry, or let's say any other domain, right? And learn that domain, because that is where you can find a lot of uh, questions that people try to answer using data science, right? So as you gather the domain expertise, this feature extraction you can do in a much more creative manner, because for feature extraction your creativity is the only limitation that you can, that's the only boundary that you have, right? So there's no right or wrong way of doing things. You can explore and extract as many features as possible. Um, so this is, as I said, this is more important than using some fancy techniques or like state of the art ML algorithms or whatever the thing that is in hype today. You can try it out, yes, but before that, feature extraction is very important step. right? As I shown in this kind of small image also, it's like finding gems and diamonds in this vast amount of data that you, right? So you have to keep on searching, try different methods so that you can extract meaningful features, right? Uh, so this comes mostly in handy where the original data that you work with, when it doesn't provide much features to work with, right? Extracting meaningful features will make or break, or will define the success of your data science project, right? I'll give some context to this, some examples, right? Now this is again from a financial institute. This is not sample data that I not sample that some generated synthetic data that I wanted to show you, right? Let's say you have a table for customers payment history, right? So usually a payment history table will have more columns, but predominantly what you have is these things, right? So the payment will be made for the contract, right? Let's say in this case a single contract I have chosen A001, and you have the payment date, right? So June 1st, August 15th, May 2nd, and September 2nd and September 25th, and 10th of October 31st, right? Then these amounts have been paid, right? So let's say this is a leasing company, let's say, right? And then you have the contract master, right? So this contract A001, that this person, the owner of the contract has to pay 12,500 rupees as the installment, monthly installment, or what you call the EMI, equated monthly installment, and the contract duration is 48 months, and this vehicle type is a motorcycle, right? Now, now what kind of features that we can extract from this, right? So that is now, because let's say if you want to run you want to understand similar customers, let's say you want to run a clustering, uh, but you can't run a clustering when the data is in this form, right? For usually to run a clustering for a single contract, you need to calculate multiple features, right? You need to have a lot of dimensions for a, I mean, here the observation is a contract, right? And the dimensions are different features. Now here you don't have that data. This data is like for a given contract, you have uh, multiple rows of data, right? Uh, right. So so now this is the data that you have, right? You may have a lot of other data sources to work with, but for this example, I have taken these two tables, right? So then what you can do, right? So then couple of things you can do, right? So now let's say this is a leasing contract. So usually for each month, what you call there's another table called portfolio is there. So what it says is that it will have for a given reporting month, right? For a given contract, some calculations that are there, right? What is the total areas this contract has? How many rentals due, right? What is the exposure? That means how much this customer has to pay, right? Those things will be there. So I have taken a sample few columns of it, right? So we have the same contract now. Now you have the reporting months, and you have the total areas, right? So on June, that contract they made the entire payment 12,500. So there's no areas. On July, he hasn't done any payments, right? So this areas builds up, right? So then 12,500 is areas. So likewise, I have calculated the areas amount based on the payment that this contract has made, right? Now, based on the payment history, what kind of features we can calculate? Um, can someone, I mean, by looking at this table, payment history, can anyone give your feedback, your thoughts? or maybe you can comment. What kind of calculations you can do from this payment history? Right. So we can do some things like this, right? Oops. Okay, fine. Uh, yeah. So I was telling, now you have the, the monthly rental, the EMI, the payment amounts have been made. So you can calculate uh, something like this. How many payments per month this customer made, right? So on June, he has made one payment. On July, zero payments. On August, one payments. On September, two payments. And on October, one payment. Very, very simple calculations, right? I mean, simple group by and aggregate, right? And also you can calculate the, let's say you take the EMI, the equated monthly installment, as a base, and compare to that how much, whether this customer had paid, right? Whether is it in full, that means equals to 1, or if they has paid more than the EMI, then it will be more, the EMI paid percentage value will be more than 1. If there's no payment or partial payments, it will be value between 0 and 1, right? So you have this EMI paid 1, 0.45 to 0.25, right? He has made two payments on that day. Probably he got a bonus or extra income. Somehow he decided to clear some dues, right? Probably that. And on again, on October, he slightly did an overpayment of 1.03, right? Now, and again, you can calculate the rental arrears. What's the arrears amount as a percentage of the monthly rental, right? So same kind of a division you can apply. And on what you call June, there's no arrears, zero. July, there's one rental arrears, and then 1.54. Then it's reduced to 0.3 and reduced to 0.27. So likewise, you can calculate, right? I'm not saying these are the only three features that you can calculate. If you think through, you should be able to calculate some other simple calculations like this. Because in the data in its original form doesn't provide you any features, right? So you have to, this is why you need to speak to the client, get their expertise also, think about it, you use your creativity, and maybe you can extract more features than this, right? Now, one of the other features that you can extract is the day. You can check the days, number of days, difference in days in between payment, right? So from the first payment to the second payment, there is more than 45 days of difference, right? Maybe that could be a feature, right? The day difference, right? So you can think lot of areas, lot of aspects as such, and then extract as much as possible features, right? At this stage, extract as much as possible, right? So um then what you have to do, still you have, like, you haven't this data is not ready for clustering or any like, to send to a machine learning model, right? Because now still for a given observation you have multiple records, right? Okay, but at least now you have calculated some raw features, right? Now let's say you have that. Now we have some raw features you have calculated. And after this, you have to transform this data, or rather another group by another aggregation layer has to be added, so that your data will be in this form, right? So for a given contract, you have to calculate many features as you can. There's no limit to that, right? Uh, you can, let's say, n number of features you are going to calculate, right? So what are the options that you have now? Uh, can I get some feedback from you guys? Right? What kind of aggregations can we do at this stage? Anything, just say anything. Anything is possible here. All right. So I'll move forward. So what you can do is you can do something like this. Very, very basic level calculations you can do, right? You can have some simple aggregated statistics, right? You can calculate the average of a particular, let's say, average number of payments per month, average value, the deviation of it, the minimum, maximum, the whatever the some other, go to aggregations that you can do. Maybe not the sum, but I don't know, still maybe, right? So those things you can do. That's one way of looking at it. But the moment you stick to that paradigm, like the moment you think that okay, these are the only calculations that you do, you there's there are two things, right? There will be obviously, I mean, when it comes to like simple aggregated statistics, there could be like very minimum number of choices that you have, right? If you take average, median, the mode maybe, and then the standard deviation, the variation, and then let's say coefficient of variation, like minimum, maximum, right? So like very minimum things you can calculate, and only you can calculate is about the center and the spread, right? Mainly those are the calculations that you can make: center and the spread and the extreme values, maybe minimum, maximum, 75th percentile, something like that, right? um Now, but if you look at this data again, right, now you have the data, or rather your raw features has been calculated for a given month, year, month, right? So this is a timeline, right? Your reporting month is a timeline, and this is a, then it can be can be considered as a time series, right? So the next option that you have is you can extract time series features, right? Now here I have just mentioned TS feature 1, TS feature 2, TS feature 3. You can extract as many as you want, right? It could be 300, 400 different time series features you can extract, right? There are packages for that. If you're interested, we'll let you know. But that's not the point. It's not a point. The point is not the package or what to use. The point is that now you have a lot of information you can capture, a lot of signals you can extract, right? You can extract the lag related features, uh, the Fourier transformation related features, right? And the energy, the number of peaks, right? So a lot of different things you can capture now, right? And that will give you initial pool of features. Now you are rich in features, so that later if you want to do a feature reduction, or like principal component analysis, some level of feature reduction, now you have a pool of features. If you go with this, you are feature poor basically, right? So then you will have you haven't extract the essence from your data. That is why I'm saying feature extraction is kind of finding the gem. Finding the gem is come during the latter stage, where you find the most important features, stuff like that. But before that, you need to at least get this entire possible set of features that you have to extract, right? So that is what is required. That is what you do have to do at this stage. That is why feature extraction is one of the most important step in your data science journey, right? Without features, you can't do anything, right? I mean, it said that data science is about extracting meaningful features from the data, right? So modeling and everything comes next, right? So this is the main message actually that I wanted to pass today with an example to show you the importance of feature extraction, right? Now here I have only talked about some numerical features, right? If you are working with text-based data, then that's a different story, right? So you can extract different set of features. But what I'm trying to say is try to be creative as possible, right? So now you have, assistance from the generative AI models, like, tell your story, like, challenge it and get feedback from it, and, see how many types of different features you can extract. The more, the better, right? So that's the main thing. I mean, feature extraction is the kind of the most creative process of your data science journey. Rest is more like, standard stuff, right? Right. Then once you have the features, now you can, create your model and, start analyzing. Here involves some kind of learning algorithm, right? Supervised or unsupervised learning algorithms. And some of the essential tasks that might become here is that you might have to scale your features. There could be some missing values in the feature extraction process. How do you handle them? Whether you input with zero or use other sophisticated imputing techniques, right? You may have to run clustering, try to understand the groups, right? Sometimes it works well, sometimes it doesn't. You have to change the algorithm, run it again, right? A lot of experimental phase comes in, right? So you have to like try different things and, try to get the most possible, best possible outcome that you can get. And then when it comes to, supervised learning models, you have to do cross validations, parameter tunings, right? Those things. And we had to run multiple different models to select the best, right? So this is more like experimental phase. And let's say you finalized that model somehow, you came up with a, let's say, in this case, actually, what you can do is you can understand different groups, right? Based on the payment behavior. Let's say you did that, right? And now you want to present it, right? I'm sorry, I missed one thing, right? So in this process you will have like mix of different emotions, right? You will get like, oh no, kind of emotions, and you'll get like very happy emotion, like aha kind of moments, right? But oftentimes, sometimes you may have to, at this stage, you have to go back to the business problem, revisit the business problem. Maybe you feel like, okay, if I have this data, if I have this column, I could have done a better job. So you may have to go back to, like, speak to the IT team or whatever the data owners. Then you need to get that, right? Then you have to go back the feature data cleaning step, feature engineering step, again do the modeling, and then see, right? So you may have to go like multiple cycles like this till you get satisfied with an answer, right? That also happens, right? So once you do that, let's say you have identified whatever the groups, and now you have to present the results, right? So in presenting the results, can go with a simple, slide deck based approach. I mean, you can prepare slides, or can go for a written report, or else you can present it from a dashboard. If dashboard is one of the expected deliveries, then you can also create a dashboard, or else even sometimes creating dashboards helps, right? Because those are interactive ways of communicating. And now here you may have to deal with a lot of like variety of stakeholders, right? And they might have different level of understandings and expectations from data science, right? So some expect to do magic, right? Some has some, like, some doesn't trust it. Some believe that, okay, the current way of that I am working is the only way to do it, right? That is the kind of, that is the only correct way that you can do it, right? So different people have different opinions. Some has very technical kind of approach. Some will have very non-technical. Some will ask very specific questions. Okay, what if these things happens? How your model will react, right? They are like questioning edge cases, right? Sometimes you can't answer that also, right? So you have to handle everything, right? So it's not that easy, but with practice also, I mean, we are also, still learning, and each time we also make mistakes, and then we'll also come up with a different strategy, or rather better strategy, right? So software engineers are there, domain experts are there, C-level executives, right? And project managers are also there. Like, so the project managers sometimes mostly uh, ask about the timeline, the percentage of completeness of the work, right? So they think about the time mainly, right? So then, okay, the presenting has two aspects, as I said. One is to present through this other, like, material based way, right? Slide decks, dashboards, whatever. And probably you might have to deploy your model also. That's the other way of, like, in a way that's also presenting, right? Presenting to the machines, right? Your model. So then you have to work with mostly the virtual machines, right? So Linux based virtual machines. Then the machine learning ops or ML ops comes into play, because you have to, like, keep your model libraries, right? So you have to, if something happens, you have to retrain a model and then point it back, so that the your solution will run without any interruptions, right? Hopefully, right? So those things you have to think about, and I think you guys are, know about those very well, right? So then the most important thing, I think, as I said, you have to iterate, right? At each of these stages, you have to iterate. So now, uh, compared to traditional software engineering projects, I think software engineering also you have to do iterations, but data science projects are more iterative than that, right? So you have to understand it, and also stakeholders who are expecting something from the data science also need to understand that data science is iterative process, because your end goal is not so clear, right? It's in a way clear, but the path that you want to take to achieve that goal, there are different paths you can take and different roadblocks you might hit, right? So then you have to alter your strategy and go, right? So those things are there. So therefore, it's an iterate by nature, it's iterative process, right? You can't avoid it. And some recommendations, as I believe, or also these are textbook ones as well: fail quickly. It's, you're going to fail at one point or the other. You quickly prototype, like, try, don't think too much. I mean, think to a certain level, but then execute, right? And then, present the results, and then get the feedback, right? So mostly the initial feedback that you get might be, not the best, but don't get upset about it, because that's a part of the learning, right? So fail as quickly as possible. And when you are doing running your code, automate things as much as possible. If possible, ideal case, if you can get everything to a simple single script where it's connected to a lot of functions, and nicely integrated, and running a simple command in the terminal. And if it does all the data cleaning part, or a data extraction part, and then run it through the model and get the outputs, and run it, try to a database, or then from that to a dashboard or whatever, then that would be the kind of the ideal case that you can aim for. But if not, if you can at least have like 3 4 chunks also, that is good, right? So keep your code modular, right? So you can't do it at first, right? So initially you try to get a solution, right? So you might be working with a lot of notebook style I mean IDEs, right? And then, but ultimately, I mean, once you can use notebooks for experiment purpose, but then soon after that, move it to a proper script, right? Obviously, version controlling, you have to work on that, right? Some version controlling method, probably Git, let's say that's the most common. Use that, so that you have everything nicely documented. And also, in case something happens, let's say if you're working on a virtual machine, if you want to like change the project to something else, then still you have your code, right? So those things are important. And maybe very very obvious ones, add comments, right? Sometimes we are very lazy to add, comments, because by at the time we are doing it, we know what we are doing, right? That's for sure, we know. But after, let's say, after a month or two, you go back and you suddenly find a issue. You look at the code, like, many multiple, let's say half an hour or so, and still try to figure out what has gone wrong. So adding a simple natural language comment doesn't harm, right? So do that as much as possible. Right. So those are kind of the whatever the things that will you will come across with the real world data science project. And there I put a lot of emphasis or focus on feature engineering or feature extraction part. In the next part, the last 10 minutes of my talk, I want to discuss about the lessons that I've learned, right? By my experience, right? So they could be some fragmented kind of ideas to share with you, right? So but this what I think you know it's worth sharing with you guys, right? uh, so there are a couple of things, right? The first thing is data, right? So as I've said, like, sometimes check basic level statistics per column, do it, and then create, or maybe create a report, or, like, ask from the data owners whether this is right, whether this is wrong. Ask questions as much as possible, clear all the doubts you have. Still, it won't be enough, but still, ask as much as possible. And as I said, maintain a data dictionary, so that your you as you're working with your data, as you do any changes and everything, your data dictionary will also get updated, so at a given point of time you have up to date uh, log of your data. When it comes to code, yes, use large language models to generate code, but validate as much as possible, right? For different types of data, apply and see whether you get the intended result. If not, very don't check for one record. Okay, that works fine doesn't mean everything else has worked fine. So you have to, like, check multiple times. Now, if you're working with large data, right, like, let's say gigabyte size of data, I think shifting to Parquet file type and working with polars in Python or R works really well, right? It saves a lot of your computation. It's very efficient, and also Parquet has this columnar data structure, so it helps to optimize your computations, right? And now, when you work with simple data sets, when you work with, let's say, Python notebooks, IPython notebooks, or whatever, in Python in general, let's say, uh, I mean, your memory, you have enough memory to play with, so you create a lot of variables, and it doesn't matter actually. But when we work with large data, when you have multiple variables inside your Python script, your memory will, eventually, like, loaded in full, and your script will crash, right? So, if I mean, use as fewer objects as possible, fewer variables as possible, and whenever you feel that you no longer need that variable, immediately after that, use the delete keyword and put the variable name. So that variable will be deleted from the memory. So you save the space, and then you can run your, like, if you run heavy computations, you have your memory saved, right? So sometimes your notebook crashes, you don't know why, right? Then only after a couple of times you're checking, only you'll realize that okay, maybe that is the case, right? But using delete keyword is one of the best practice that recently I found to be working for me. And as much as possible, convert things to functions, right? And then pass to the scripts. Version controlling, I've mentioned this. And when it comes to communication, right, keep things simple, right? I mean, you can write emails, lengthy emails, but I mean, it's most of the time it won't do much, right? If pick up the phone and call to colleague or send a text and confirm it if that is possible, else send an email. But whatever the communication you do, keep things simple and to the point, right? Everyone, I mean, when you even writing an email, put put your time and effort, like think about the other person who's reading this email, right? Don't just type something and send it for the sake of sending it, right? Because the other person who's in the receiving end has to put his time and energy to read it, understand it, and reply, right? So you have to have a respect to the other person's time and energy also, right? So then once you do that, the other party, whatever the other party, will also pay the same respect to you, right? So keep your communications very clear and simple, right? Think that you are right, the other end, you are the person who's reading this email. So respect that person and send it, right? And give proper, like, updates where necessary. Don't like give all the time updates, then you don't have work time to do your work, right? But a good thing would be to maintain a log of your own log, like maybe a small Excel, again a Google sheet. On this day I did this, I informed this person, that kind of your own log you'll maintain. Else what will happen is, most often sometimes problems, people ask, okay, why didn't this happen, like everyone now get panicked, and then you have to like go through the mail chain, and okay, I on this day I said this, but this guy hasn't replied to me, right? These are, I mean, for data science work, these are unnecessary drama, right? Try to keep things simple and professional, right? So that is communication wise, that's important, right? Else you will spend a lot of time in your day-to-day time with for those some non-value adding activities, right? And whenever required, learn to say no politely, right? Sometimes, you know um, people will ask a lot of modifications, different kind of requirements, right? I mean, which might not add value, right? Learn to say no in a proper way, right? I mean, in a polite way, right? So in terms of productivity, I mean, I these are things that I use, right? So I keep Obsidian as my note-taking app, right? Because in Obsidian you can link these markdown files to one another, and you can easily, what you call this method is called settle casting. Uh, then you can easily, search for the knowledge that you have, right? Sync it to OneDrive, and then even if your laptop crashes, you can shift to a new laptop, get to your OneDrive or whatever the other cloud storage, connect to Obsidian, and your notes are saved, right? It's very easy, very convenient. There are other tools as well. I haven't used them for to be honest, but Obsidian so far has worked for me. Canva for creating presentations, very useful, very easy. Uh, it has the whiteboards where you can have your, you can add your diagrams, whatever. Super friendly, super useful, super useful tool. And I'll keep a small three kind of a three column to do list I'm maintaining, like to do, doing, done kind of thing. So for that I use Trello. Again, these I use free tier. Canva we have a paid subscription, but everything else, yeah. So Trello I use a free tier. I use this simple. Now, when you say like, task management, don't make a project out of it, right? Keep very simple, right? Just to see what you are doing, what you have done, what has to be done. That kind of setup is enough. Um, for large language models, you can choose whatever you like, but recently I found Gemini to be useful because in our company runs in a Google based services, and we have Gemini as a service, so our data won't go out. So it's within our it won't be used. It says it won't be used for training purposes, so we trust it. So we do everything in Gemini now. And it has what you call the gems, like coding assistants, email writing assistants, etc., learning assistants. Those things you can use, very very helpful. And I have kept this in brackets, right? But I find this personally to be very useful. because you all the time, I mean, if you take the most of the time, I'll be working with my keyboard, right? So touch typing, I've spent some time and effort and learned it, and it worked well for me. Now I can, don't have to look at the keyboard and type it. Probably, if you think that is a good skill to have, try considering that as well. It will boost your productivity a lot. Uh, yeah, so that's about it. And finally, what I want to show is this. This is a person that I follow on LinkedIn, right? She writes genuinely on LinkedIn about, like, to anyone who's becoming trying to be a data scientist or data analyst. She gives a lot of advices. So what he or she says is that, comparing yourself to others can be discouraging. Focus on your own progress and set your own personal benchmarks. So it's you versus, right? So celebrate whatever the small victories you have, whether you learned a new tool, feature, anything, right? That's your wins. Quick, those wins, celebrate them, right? So you have to remember, what you have to remember is that everyone's learning path is different or unique, right? Don't compare yourself to others, right? Uh, so that's what's important, right? Else, now in this domain there are a lot of technologies, new things comes in daily, right? You feel like you're not up to date, but no, I mean, work on your project, whatever the task that you do now, work with passion, right? Try to deliver your best every day. Show up, deliver your best, so that adds up, right? So that's actually what I wanted to share with you guys today. Um, Thank you for the time. I think I took like 1 hour and 5 minutes or so. But if there are any questions, I can answer. But Yeah, so there's one question I think got from Channa, saying that, can you give an example of a complex high-level data science scenario? It's asking. So the one that I actually mentioned is actually a complex scenario where you want to identify, classify different customer groups. I mean, rather identify different customer groups. Later, maybe you can classify it. So that is one thing we have in finance sector. That is one case that we can think of. In others also, like, every problem, I mean, has complexities in their own complexities, right? It could be maybe a simple, I mean, you can't say it's simple, right? If you take even a business intelligence project, that's it's a very complicated project, right? So you need to identify the data sources, type of analytics that is required. You have to validate a lot, right? I haven't even actually discussed that. You have to validate a lot with the stakeholders, right? Else, as I said, if don't trust the product, what the solution that you give, then there won't be, I mean, the project is useless, right? So I think yeah, so that's the answer to that. Any other questions? Maybe hosts, whether you have received any questions, let me know. I can try to answer. Right. So maybe we can connect through LinkedIn, and this is my email address. If you have anything to clarify later on, even maybe you can drop me an email and we can discuss. Right. So if there aren't any questions, I guess that's from my end. Maybe Nehansa or other co-hosts, over to you. Thank you for participating in this event, and I really enjoyed it. Thank you very much, and I wish you all the best for your as aspiring data analysts, scientists. Like, come to the industry, do good. Let's keep in touch. we'll do something good in this domain that we have learned, and we'll contribute somehow to. Right? Thank you.
Thank you so much, Mr. Thenuwan, Jayasinghe, for that insightful and eye-opening session. We truly did enjoy a lot listening to you. So, your perspective on revisiting the fundamentals of data science truly helped us understand that it's not just about the model, but the strong foundation that supports. We're grateful for the valuable knowledge you shared with us today. So, before we officially wrap things up, we'd love to take a group photograph. So, please, those who can, turn on your cameras and give us your best smile. Those who can turn on their videos, um, please do so we can take good photographs. Okay, so I think Ramida will be capturing the picture. So anyway, um, so all I have to say is don't forget that this is just the beginning. We've got more exciting sessions lined up as a part of DataStorm 6.0. So make sure to join us for the next webinar and stay tuned for all the updates. Um, until then, yes. Until then, thank you once again, Mr. Jayasinghe, for being here with us today. And thank you all of you for joining with DataStorm 6.0. We look forward to seeing you again soon. Thank you and have a good night.
Thank you. Good night.